Good evening, students. Now we shall begin with the next unit in the Determinant chapter, that is minors and cofactors. In this section, we will learn to write the expansion of the determinant in the compact form using minors and cofactors. How can you define the term minor? The minor of an element is a determinant of matrix obtained by deleting its rows, means ith row and jth column containing of that element. If the minors are multiplied by the proper signs plus or minus, we get cofactor. Have you understand about the minor? How can you define the minor? Minor of an element is the determinant of a matrix obtained by deleting its rows and columns, means ith row and jth column containing that element. If the minors are multiplied by the proper signs plus or minus, we get the cofactors. The signs to be multiplied are given by the rule plus, minus plus, minus plus minus, plus minus plus. Yes? In other way, we can define the term minor. Minor of an element A of ij of a determinant is the determinant obtained by deleting its ith row and jth column in which that element lies. This is also the definition of minor. How can you define? Minor of an element A of ij of a determinant is a determinant obtained by deleting its ith row and jth column. For example, let delta is the determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. In this determinant, minor of element 4 is given by, always minors are denoted by capital M. Generally consider a determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. If minor is denoted by capital M, 4 is the position of M21 element because A21, A22, A23. Yes? So for that purpose here M21 belongs to the element 4. The minor of element 4 is given by. According to definition, you leave this row, second row and first column, ith row and jth column according to definition of minor. This row, this column, whatever the elements remaining, 2, 3, 8, 9, means minor of element 4 is given by M21. M21 is equals to 2, 3, 8, 9. And its value becomes product of principal diagonal elements minus secondary diagonal elements. 9 2s are 18, 9 2s are 18, minus 8 3s are 24. That's equals to minus 6. Is it clear? Is it clear? So it is minor of an element is denoted by m of ij. M of ij. Am I right? Then definition of cofactor. Cofactor of an element A of ij is denoted by capital A of ij. Yes, it is denoted by capital A of ij. Is defined by A of ij is equals to minus 1 to the power of ith element plus jth column. Ith row plus jth column. How do you find the cofactor of the elements? Significantly, it is denoted by capital A of ij is equals to minus 1 to the power of ith row plus jth into minor of that corresponding I and j. Yes? How can you define the cofactor? Cofactor of an element A of ij is denoted by capital A of ij, and it is defined by the equation A of ij is equals to minus 1 to the power of ij, I plus j into m of ij. Consider the example delta. Delta is equals to 2 minus 5, 3, 4. In this determinant, cofactor of all is given by, cofactor of all the elements is given by A11, A12, A21, A22. Yes? 2 into 2 order of the determinant. A11, A12, A21, A22. Hence, the cofactor of each element is given by. Always cofactor is denoted by capital A. Hence, A of L1. The cofactor of element 2 is given by A of L1 is equals to minus 1 to the power of 1 plus 1 because it belongs to the ith row means first row and first column, hence 1 plus 1. Its minor is 4. The element of 2, the minor of the element of 2 in second order determinant is 4. Hence, minus 1 square is 1. 1 into 4 becomes 4. Am I right? Then, how do you find the cofactor of the element minus 5? It is A12 position, A of 12th element. A of 12th element of cofactor is denoted by capital A12 is equals to minus 1 to the power of first row 5. This belongs to the first row but second column. First row, second column. Hence minus 1 to the power of 3 into cofactor of minus 5 is 3. Hence multiplied to the 3, minus 1 to the power 3 is equals to minus 1 into 3 minus 3. Am I right? Then the third point, third element of the determinant is 3. Cofactor of the third element, that is 3. Hence, A21 is equals to minus 1 to the power of. This belongs to the second row, first column, second row, first column to the power of minus 1 into the minor of this element is minus 5. Minor of this element 3 is minus 5. Hence, minus 1 to the power 3 into minus 5, minus of minus equals to plus 5. The last element is 4. cofactor of 4 is defined as A22. A22 is the cofactor of fourth element. Hence, A22 equals to minus 1 to the power of 2 plus 2 because this element belongs to the second row, second column of the determinant into M22. Cofactor of a minor of this element is 2. Hence, minus 1 to the power 4 into 2, that becomes 2. Hence, the cofactors of all these four elements is 4, minus 3, 5, 2 respectively. In this manner, we can find the cofactor of the second order determinant. But third order determinant cofactor method is different. Cofactor of an element is denoted by capital A of ij. Minor of an element is denoted by M of ij. Yes. Note, if elements of a row or column are multiplied with the cofactors of any other row or column, then their sum is 0. The sum is 0. Yes. Then continue with the problem. One of the problem given for your example. See here. Write the minors and cofactor of the elements 2, 1, 1, 3. How can you find the minor and cofactors of a determinant? Delta is equals to 2, 1, 1, 3. Yes, see here. The minor of element 2 is given by, it is the first element belongs to the first row, first column. Hence, minor of the element 2 is equals to, denoted by M11, that's equals to 3. That's equals to 3. Minor of element of second, that is 1, is equals to, that is in the M2 position, means A12 position. Hence, minor can be denoted by capital M12. Therefore, the minor of the second element M12 is equals to 1. It is 1. Then, minor of the element, third element, that is in the A21 position, that is denoted by M21. Hence, the minor of one element, minor of the element 1 is equals to M21, that's equals to 1. And lastly, the minor of element 3, it is in the A22 position, hence it is denoted by M22, then its minor is 2, because the minor of 3 is 2, minor of 1 is 1, because minor of 3 is 2, minor of 1 is 1. So, hence the minor of 4 elements, minor of 2 is 3, minor of the element 1 is 1, minor of the element 1 is equals to 1, and minor of the element 3 is 2. Hence, all the 4 elements minors are given. But how can you find the cofactor of each element of the given matrix 2, 1, 1, 3? See, The cofactor of an element 2 is always denoted by the A11 because A11, capital A11 represents the cofactor. Small a11 is the element belongs to the corresponding determinant in the first position. Hence a11 is equals to minus of 1 into first row, first column minus 1 to the power of I plus j into minor of that element. Minor of corresponding element, that is M11. That's equals to. The minor of the first element 2 is 3. Hence, minus 1 to the power of 2, that's equals to 1 into 3, that's equals to 3. That's equals to 3. And cofactor of the element 1, that is A12 position, that's equals to capital A12 is equals to minus 1 to the power first row and second column, first row plus second column into the minor of the 12th element. Minor of 12th element is 1. Already we found. Hence minus 1. Minus, because minus 1 to the power 3 equals to minus 1 into 1, that's equals to minus 1. Similarly, cofactor of element 1 means third element, that is 1, which is denoted by A21. Then capital A21 defines here the cofactor of third element. That's equals to minus 1 into the power 2 plus 1. Because A21 element belongs to the second row, first column, hence ith row plus jth column minus 1 to the 2 plus 1, that's equals into M21 minor, into the minor of element M21, which gives minus 1 into 1, that's equals to minus 1. Cofactor of the element 3 means last element, fourth element, that is in the position of A22. Hence cofactor is denoted by capital A22. That's equals to minus 1 into the second row, second column into the minor of M22. Minor of M22 is already found 2. Hence minus 1 to the power 4 equals to 1 into M22 means 2. Hence the cofactor of each element is 3, minus 1, 2 respectively. Yes, in this manner we will find minors and cofactor of the determinant 2, 1, 1, 3. Second order determinant this is. Okay, then listen.